Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone back into the Computer America Show. We hope that you are doing well and you are ready for today's program, because today on the show, you may have guessed, it is Friday, and that means, you get your weekly dose of Ralph Bond. You get it here. And he is our science and tech trends correspondent. And you can guess that, these stories are going to be great and uplifting. Because, not all of us can be, prized thoroughbred horses that sell for $10.5 million at auction. No, some of us just have to find our little joys where we can get them. And sometimes that is in the world of science and technology. So, with that being said, everyone, welcome into the program, computeramerica.com. That's where you'll find everything, including past shows, future shows, show notes, articles, all that and more. And really want to highlight the idea of the show notes, because Ralph comes on and he puts together these great show notes that have links, sources, videos sometimes associated with them, that if you are simply listening, you can come out to the website and you can check out all of that on your own. But, of course, if you are listening, sit back, relax. If you're watching, thank you so much. And everyone, let's go ahead and bring Ralph on. So, once again, science and tech trends correspondent. He contributes here and, of course, just talks about some really fun, good, lighthearted stories that probably you have missed. Not all the time. Sometimes there are stories that got a lot of attention but deserve a little bit more. And these are stories that are also, very much things that you should know about. So with that being said, welcome back onto the program. Ralph, how have you been?
I'm doing okay, and it's another crazy, busy news week for everybody out there in the world. But what we're going to do is something very uplifting and special. So if you're brand new to the show, welcome first and foremost. And let me explain. What Ben and I do every Friday is highlight 4 articles that show us key trends and developments in all things science and technology. We really open the umbrella wide. Of course, artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, construction tech, space research, physics, you name it. Here's the thing, though. If you're new to the show, we want to stress this. We're going to give you hope for a better future, thanks to amazing breakthroughs happening every single day in the world of science and technology.
Absolutely. And I think we're going to, Ralph, why don't we start with story number 1? That sounds like a good place to start.
Yes.
Let's talk about batteries.
This is so great. I love this story. It comes from techexplore.com. Get this headline. This gas battery turns CO2 and nitrogen oxides, pollution, into electricity while cleaning the air. Is this not the penultimate win-win? Wow.
It's amazing.
It is amazing. And we have a link to the research paper and a link to the original article. Again, what Ben and I are going to do is just give you some highlights. If you really want to dive into this, come to get the show notes, get those links, and dive deeper if you so desire. So a revolutionary new gas battery technology developed by a team of researchers from, and I'm not even going to try to butcher this name. It's an outfit in South Korea.
You coward, Ralph. I got this.
Go for it.
Sungkyunkwan University. There we go.
Thank you.
I got it.
Thank you, Ben. I couldn't do it. But a great outfit, a great university in South Korea. Salute to the South Koreans. They're just amazing. Has emerged a dual benefit solution for environmental protection and energy production. Again, win-win. This innovative system is designed to simultaneously clean the atmosphere and generate electricity by capturing harmful greenhouse gases and pollutants. Now, of course, immediately, how does this work? Well, traditional batteries store energy using solid or liquid chemicals. In contrast, this gas battery utilizes common air pollutants, specifically carbon dioxide and nitrogen oxides, as active components for its chemical reactions. Wow. As these gases pass through the system, A specialized electrochemical process converts them into less harmful substances. During this conversion, the chemical energy stored in the pollutant molecules is released as usable electrical power. Essentially, the device acts like a filter that pays for itself by contributing electricity back to the grid. Okay, wow.
And obviously, just want to highlight this again.
Yeah.
You have a lot of questions. We have a lot of questions. That's okay. For time's sake, we can't get into all of them, but come out to Computer America and you can see the research paper yourself, and at least
Yes.
pick through the abstract and answer some of those. But still, very cool technology.
Extremely cool. So let's highlight some of the key benefits of what they're doing. Well, air purification, it directly removes nitrogen oxides, a major component of smog, and CO2 from industrial exhaust or ambient air. You know where I see this happening? Putting these devices, these so-called gas batteries, near major manufacturing situations that are emitting a lot of nasty air. And then,
I was just thinking, and one of the questions that I immediately had was, what concentration does it have to be to generate electricity? Because is it just general ambient air, stick it outside your door and, you get a trickle of electricity? Or, Ralph, is this something like you have to put it in the exhaust of, let's say, a coal power plant or a natural gas power plant to get that concentration? I don't know.
I wondered the same thing myself. And then going on, though, for the benefits stack here, sustainable energy. It provides a way to generate power without burning new fossil fuels, using waste gases as the fuel source. And efficiency, the system is designed to operate at room temperature, making it more energy efficient and scalable for urban environments or factory smokestacks. There you go, factory smokestacks. Yeah. That's exactly what we were thinking about a moment ago. And to wrap it up, by turning harmful emissions into a resource rather than a waste product, this technology represents a significant step toward a circular economy where pollution is repurposed to meet the world's growing energy demands. Now, it's early research, folks. I'm sure there's many things to have to be worked out, and how do you deploy this, and how do you take advantage of it? But I just love this idea of taking pollution from the air, bibbity bobbity boo, out comes electrical energy. How's this bad? Right, it's great.
Yeah. And of course, just seeing the cover image here, it looks like a Borg cube. I know it's just like a science paper, but it is at least published in the Royal Society of Chemistry. So that is a very well regarded
absolutely
chemistry paper. So there has to be something here to it, Ralph. Will it solve everything that we have in the world? No, but might it be part of the puzzle? Possibly, quite possibly. Yeah. So very cool there. And again, come out to Computer America. You can check out the show notes and read the article and read the paper yourself if you want to know more. But still, once again, Ralph, turning waste into a usable product, in this case, wasteful gas into electricity, that is something that I think everyone can get behind. So
absolutely.
Very cool. Story number one. Story number two, jumping on down to the next page here. And we're going to talk about, well, Ralph, we've seen robots in the construction field. I think it was last week or another week that we did rebar tying, where essentially it was a robot that would go through and essentially tie rebar.
Right.
Essentially have robots, obviously, the construction field, very messy. It's very planned, don't get me wrong, but also it's very reactive. It's not a great place for robots. It's not a great place that you can, set something up and it'll just go. Robots need to be very in a more controlled environment. Well, story number two, we might be seeing that robots might be meeting us halfway in this challenging working environments.
Exactly right. Yeah, no, this story is a construction technology related. It comes from constructionmanagement.com, a great outlet, by the way. Headline, Humanoid robot takes first steps on construction site. And this is of particular interest to me because the last 10 years of my career before I semi-retired, I guess you would say, was with Autodesk, and specifically in their architecture, engineering, and construction division, in which I just learned so much about technology in that world. And I love the construction technology field. Second, my son-in-law is a construction manager for Google, of all things. So I shared these stories with him immediately. So here we go. Construction firm Tilbury Douglas is the first major UK builder to use a humanoid robot named Douglas on an active job site. Douglas does not perform physical labor. So, Ben, this is a key point, I think, to your comment about, does a humanoid robot really make sense in a messy, chaotic construction site? Well, they're saying, well, we're not going to ask this thing to do physical labor. Instead, it handles data collection and administrative tasks. Ding, ding, ding. Smart. I think that's really smart. So let's talk about what this robot does. It navigates and maps the site autonomously using LiDAR and 360-degree cameras, captures daily 360-degree imagery from the exact same coordinates, feeds data into health and safety workflows, that's kind of cool, and performs laser scanning to create detailed point cloud models that can detect defects humans may miss. How about that? That's pretty cool.
It sounds like now instead of having, what was the joke about construction and, having like 6 managers over like one guy digging a hole. Now you just have one robot manager who takes exact, point cloud 3D modeling of that one guy digging a hole. So yeah, cool.
It is pretty interesting. So here's another key point: efficiency and workforce impact. Automating these tasks that this robot Douglas does saves the site team roughly 40 hours of administrative work per month. And that may not sound like a lot, but it's significant. It frees human workers to focus on technical construction tasks rather than paperwork. That's important. Supports the industry during a period of significant skills shortages. Wow. Okay.
Yeah, it's one of those areas where, again, automation coming for jobs, but at the same time, some of these jobs that we're automating, Ralph, like time and time again, I think about these jobs that are getting replaced and automated. You feel you really feel for the workers. It's how they support their families. It's it's something that is definitely needs to be tackled. But at the same time, Ralph, it's like if computers and automation can handle that. That does free you up to do other things. Like, you can't just push back and say, well, we don't want to lose the job. It's like, at some point, taking pictures of a work site, taking very detailed, accurate measurements that, would take people way longer to be able to accomplish the same thing. It just makes sense at some point to have robots on the work site. And hopefully, instead of replacing people, it just makes people's lives easier. So that's my hope.
And again, I think the interesting twist on this story, as we mentioned before, is that they're not asking the robot to pick up a hammer or a saw or do bricklaying or anything like that. It's managing administrative work. And I can tell you from what I've learned from my son-in-law and my daughter, who also works for Skanska, another worldwide gigantic construction company. There's so much paperwork, so much detail, so much tracking of projects. If robotics can help with that, wow, that's wonderful. And then the talented folks can focus on construction, not on management. So that's pretty cool. Now, here's something to talk about. This robot they're using was developed by an outfit called Unitree, a major player in humanoid robotics market. I didn't know about these guys. So in the show notes, you can check this out as well.
Yeah, I have heard of Unitree, although I know them from their robotic dog, their go-to robotic dog. So you may know, and I can pull up the images here if you're watching the video portion.
Sure.
You may know the Boston Dynamics dog.
Right.
Unitree made the go-to, which is like similar form factor. I'm sure not at all inspired by the other one or stolen or anything like that, Ralph. But it's this Chinese outfit, and they're able to make these things. I want to say for like $1,200. So for $1,200 as opposed to like $20,000 for one of the Boston Dynamic ones. Very affordable.
That's interesting. That really is interesting. So the Unitree robot, the writing of this story, had completed a 10-week trial demonstrating its value. Now, broader significance, the Tilbury Douglas, this is the construction company using this Unitree robot, sees this as a key step in its digital transformation. And the trial shows how emerging robotics can improve operational performance, safety monitoring, and workforce efficiency. So, wow, it's so interesting. If you think construction's boring, if you think construction's low tech, think again.
Yeah, no, it's certainly a field that is developing just as fast as AI. Like I know there's jokes like, let's see AI, do drywall or something like that, and it's not there yet, Ralph. But I will say that the stuff that goes around drywall, like all of the processes in construction and manufacturing and stuff like that, all of it is very much being influenced by AI. So,
And if you want, and I've mentioned this over the years many times, Ben, but I can't help it. If you want to figure out or be exposed to the most incredible technology innovation going on in the construction industry now for 10 or going on 15 years, learn about something called building information modeling. BIM, building information modeling. Your brain will just melt. It's so cool.
yeah, and of course now, Ralph, you have systems like these that will go out and get even more detailed, accurate information and data up to date constantly. So, so there you go. It's advancing. So story number 2, story number 3, scrolling on down here, and again, you can go to the show notes and scroll down because by the time that you hear this, you can go check out the show notes up on the site. But yeah, let's talk a little bit about wings that morph. So planes that actually, kind of change shape. And, I'm sure this is planned, not the usual morphing wings that just kind of explode during flight. No, these are intended to change shape.
This is one of the most interesting stories I've come across in quite a while. It comes from Aerospace Global News, wonderful outlet. Headline: AI-controlled morphing wings take flight as DLR will explain who that is, tests aircraft that reshape themselves midair in real time. What? You have to see the video that's embedded in the article. Again, the show notes have the link. Please come out, pull up that article, and play the video because it just is mind-blowingly cool.
That's goofy. That is
Isn't that
unexpected.
Something? It's weird and funny looking, but my God, the implications are incredible. So the German Aerospace Center, that's the DLR, has successfully flight tested a groundbreaking shape-shifting aircraft wing that uses artificial intelligence to optimize its performance in real time. Wow. This project, known as Morph Air, aims to replace traditional mechanical flaps and ailerons, I never can say that right, with a seamless, flexible wing structure. At the heart of this innovation is the hyper-elastic trailing edge morphing system, which of course has to be an acronym, HITEM. And unlike conventional wings that use hinged flaps, which create aerodynamic gaps and turbulence, the hyper-elastic trailing edge morphing wing deforms smoothly. It utilizes 10 small actuators distributed along the wingspan to adjust a wing's profile continuously. This seamless design significantly reduces profile drag and allows for precise control over lift. So, Ben, don't you agree that video is just whoa?
Yeah. For everyone out there who's just listening, you can imagine a plane wing and it has those flaps that kind of go up or go down depending on if, you want to push the plane kind of down or up. This is very much, I would say, if you're just listening, honestly, imagine a fish's fin or something like that. It's very organic, very, it has all these spines and it moves very organically, almost like it would be swimming through water. But no, it's not.
Here's an adjective for you: undulating.
Yes.
I mean, this thing is it's so radically. What a talk about rethinking the wing.
Yeah. Again, it looks so organic that your brain is like, it looks almost alive, and it's a little gross, but at the same time, it's a plane wing, and I'm sure it has lots of benefits.
Yeah, the only thing I could say that's negative is if, God help you, if the system, well, there is a comment about this, but if the whole system went down, then now you're really in trouble. But I'm sure they've got this all figured out. So let's talk about the adaptive artificial intelligence. Well, because managing multiple distributed actuators is complex, the German Aerospace Center developed an AI-assisted flight control system. This adaptive algorithm senses the airflow and compares actual flight behavior against its trained models, all in real time, by the way. Self-learning: if the system detects deviations caused by gusts or turbulence, it updates its internal model in real time. fault tolerance. The AI is trained to handle emergencies. If a section of the wing is damaged or an actuator fails, the algorithm automatically redistributes control to the remaining functioning parts to maintain stability. Holy smokers. Isn't that something?
I'm sure they tried to, kind of foolproof this as much as they can. My wife went on a binge recently of watching a show on, I want to say it was Disney or Discovery, called Air Disasters, Ralph. My word, the amount of regulation and paperwork and plans and things that happen in the aviation industry that happen because this one thing happened with this one airline in Peru. Now the entire industry has to do this one thing every single time. It is hard to work in new technology, but at the same time, new technology is always highly sought after in the aviation industry. So this walks a fine line, but it may make it into airlines one day.
Yeah, it could. It could. And so let's talk about why this all matters. It's sort of self-evident, but the team in Germany tested this on an uncrewed aircraft they call Proteus. And in the show notes, you'll see a picture of it. It's in the foreground there of the picture. This technology promises to make future aviation more efficient, quieter. That's an interesting point. Quieter and safer by eliminating, gaps and optimizing shape for every stage of flight. Aircraft can significantly reduce fuel consumption. Okay, that's important. And by default, emissions, marking a major step towards sustainable aviation. And additional scalability tests are planned for 2026, this year, continuing on. So this is another good example of early research. You're not going to go to the airport tomorrow and see this. Maybe you will in 5 years, maybe 10 years, or maybe sooner. Who knows? But I just thought this was one of the most intriguing aviation technology stories I've ever come across.
Yeah, no, and they even show, I guess the size of the drone that they kind of have in the first part, and then they show the plane behind it, where they show the curve of the wing kind of going up to show just how much it can flex. No, Ralph, I look forward to future testing of this.
Yeah,
and no, it's an improvement over something that is as simple as a flap. And it's, hey, if it does improve, airlines would be very keen on implementing it. So very cool.
Yes.
So, story number, I believe 3. Now we're going to go ahead and skip on down to story number 4. And, Ralph, as you get older, I think you lose neurons. Maybe you don't. Maybe you do. Maybe I'm just making that up.
Oh, yeah.
But the idea of, artificial neurons sounds pretty good because replacing what I've lost sounds like a win-win for me. So I like this. So story number 4, artificial neurons.
Yes, this is really good. Comes from livescience.com, another wonderful website. Headline, scientists invent artificial neurons that talk to real brain cells, paving a way to better brain implants. There is so much going on in that headline alone. Wow. So let's get into this. We have a link to the research paper, of course, and so on, so you can learn more about this. Here we go. Another great university in the United States. Northwestern University engineers have achieved a breakthrough in bioelectronics by creating printed artificial neurons that can communicate directly with living brain cells. Let that sink in. Printed artificial neurons that can communicate directly with living brain cells. Hybrid. Okay? This innovation marks a significant step towards seamless brain-machine interfaces. Boy, is that a trend. You take Neuralink with Elon Musk and all that bunch, and all these technologies people are trying to put into our brains to help, to cure diseases or problems and so forth. So it's not negative. It's just fascinating, I think.
It's always a fun fact to kind of keep in mind that, we talk about cutting edge technology, the best innovations that, are research and are just, really trying to hit the field. And Ralph, and it's still like the most complex thing we've ever observed in our universe is still our own brains, just the connectivity of it, the complexity of our own brains. So it makes perfect sense why, interfacing with that super complex thing, the brain, is a goal, but still, our own brain is outperforming even all these great breakthroughs. But no, it's
absolutely.
They're trying.
Yeah, absolutely. And let's get into the core innovation aspects of what's going on here. Historically, artificial neurons have been too rigid, too power hungry, or produce signals too simplistic for biological cells to recognize. Now, the Northwestern team overcame this by using electronic inks made from graphene and molybdenum. Molybdenum.
Yep.
Butchering that. Molybdenum disulfide. Okay, this is geeky. You can come out to the show notes, dive in deeper if you want to get into this. But unlike traditional silicon transistors that act as simple on-off switches, these printed neurons are dynamic. By leveraging imperfections in the material's polymer, the researchers created a device that generates complex electrical patterns, including single spikes and continuous bursts that perfectly mimic the language, as it were, of the human nervous system. This is extremely deep stuff, folks.
Yeah, I and what that really, like, you just read it and it's still there and I'm still reading it. What that really means, I probably need to go over it a couple times, but I guess by being able to send a signal that is closer to the human brain, I guess you couldn't really do that with older systems. So
Yeah. And that previous paragraph we just read, the bit about by leveraging imperfections, you would think imperfections, well, that's a problem. No, they actually figured out a way to make the imperfections of the material's polymer do this.
The
amazing thing.
The classic technology, it's not a bug, it's a feature. Yes. Very good.
That's kind of remarkable. So let's kind of highlight some of the key breakthroughs of what's going on here. Biological compatibility in lab tests. The artificial neurons were connected to slices of a mouse cerebellum. Thank you, mice, again for your sacrifice. The living brain cells responded to the artificial electrical spikes as if they were coming from another biological neuron. Oh, wow. Low cost and flexible. These neurons are produced using aerosol jet printing, a process that is inexpensive, generates little waste, and allows the electronics to be printed on soft, flexible surfaces that match the texture of brain tissue. Whoa. Now, energy efficiency. The human brain is exponentially more efficient than modern AI hardware so far. By mimicking the brain's structure, this technology could lead to computers that process massive data sets without the immense power and cooling requirements of current data centers. Boy, is that a big issue. And the medical future impact. This plug-and-play compatibility with the nervous system opens the door to advanced neuroprosthetics. Here comes the medical human benefit, okay? Future applications could include high-fidelity cochlear implants for your hearing, visual prosthetics that restore sight, and brain implants that allow paralyzed individuals to control robotic limbs with the same precision as natural movement. If you're not uplifted from these stories this week, I give up.
Once again, it's just this idea that we have to, not just copy, but perfectly mimic every process to get this idea of, prosthesis that act as, real limbs. Ralph, we're going to get there. I don't know when it's going to happen because, Ralph, every time it seems like we're super close to it, it's like, oh, scientists have figured out how this one little thing way down in the system works. And they're like, oh, wait, we didn't know how brain cells talk to each other, or we couldn't talk to real brain cells with, electrical signals, like stuff like that. It's all an improvement, and all of it makes a difference getting to that end result. So, ladies and gentlemen, there you go. Story number 4, really amazing stuff. And like Ralph said, if you're not uplifted, don't know what to do for you. But what we can do is maybe give you a couple more stories to uplift you even further. Because if you're following along in the show notes, you may notice that if you scroll past story number 4, you then hit the honorable mentions. And these are stories that are just as important, just as great, and you should definitely know about them. So if you come out to the website, you can check them out there. But Ralph will at least give you the headlines so that you can, kind of know what to look for. So Ralph, honorable mentions.
Yeah. This kind of picks up on a theme from last week. We talked about a robot that does paperwork management, so to speak, on a job site in construction. So this is kind of related to that. It comes from Anthropocene Magazine. Headline, the next big thing in sustainable construction, iron-fortified wood? Check it out. This is pretty interesting. And again, construction technology is not dull. It's fascinating. So here we go. That was the first one. The next one comes from sciencealert.com. Headline: Scientists discover an amazing new use for your leftover coffee grounds. In fact, this use is insulation material made from waste coffee grounds. Wow. I'll give you another tip, folks. I've said this before on the show. Your lawn would love your spent coffee grounds. I sprinkle them on my lawn. They love it.
There you go. No,
The grass loves it.
and really just glancing over the show notes that you've included, Ralph, I did not know. Fun fact. The world consumes 2.25 billion cups of coffee a day. And, I'm about 2 billion of that. So I get it.
Yeah. And I queue up all my spent coffee grounds into a bucket in the garage. And then when it fills up, I go out and sprinkle it on the lawn. That's a little tip for everybody. There you go. Okay, so next one comes from good old Northwestern University. We also highlighted them last week as well. Headline: Implantable. Oh, this is so cool. Implantable, quote unquote, living pharmacy produces multiple drugs inside the body. New system generates oxygen, sustaining drug producing cells for weeks. It's a little device that you would put into the body to dispense medications, the quote unquote living pharmacy. Oh my God, amazing stuff.
So you can implant multiple drugs and just kind of get them as you need. It's, again, a trend from last week, just this idea of personalized, on-demand care. It's really cool.
Yeah, it is cool. And our last honorable mention comes from the University of California, San Diego. Their website, headline: Sound waves could be used to remotely reprogram material stiffness, a study shows. This is pretty geeky stuff. But the implications, the possibilities of this are pretty darned interesting. So check it out.
There you go. So, ladies and gentlemen, all those stories and more last week, the week before that, heck, even the week before that, you can head on over to Computer America and you can find all of those stories. So I want to thank you all so much for tuning in. I want to thank you for checking us out. Thank you, Ralph Vaughn, for putting this together as always. And everyone, I hope that you have an amazing week. You have an amazing Friday. We will catch you next time. Actually, I believe as of recording this show, the following Friday, we will not have a show. So just want to throw that out there. But everyone, we will then be back 2 weeks from now. So everyone, have a good 2 weeks. We'll catch you next time. Have a good one. Bye, everyone.